Good morning, everyone. I'm Kishan Shinde, pursuing my 6th third year engineering in Sri Venkateshwara College of Engineering in domain of computer science engineering with artificial intelligence. This is my introduction. Let's see today's topic, that is collections in Java. Introduction. Any group of individual objects separated represented as a single unit is known as a collection of an object. In Java, separate framework named collection framework has been defined in JDK 1.2, which holds the collection class and interface in it. Collection interface java.util.collection and a map interface java.util.map are two main root interfaces of Java classes. Advantages of collection framework. Consistent API. The API has a basic set of interface like collection, set, list, or map. All classes that implement these interfaces have some common set of methods. Reduces programming effort. A programmer doesn't have to worry about the design of collection, but rather he can focus on the best use of his program. Therefore, the basic concept of object-oriented programming, that is abstraction, has been successfully implemented. Increases programming speed and quality. Increases performance by providing high performance implementation of useful data structures and algorithms. Because in this case, the programmers need not think of the best implementation of the specific data structure. He can simply use the best implementation to drastically boost the performance of his algorithm and program. Hierarchy of collection framework. So the yellow color represents the interface, and the pink color represents the class associated with that interface. So we have set collection as a different type of interfaces, that is set, sorted set, list, queue, dequeue, map, sorted map, navigable map, and these interfaces have been associated with their own classes. Let's see more about that. Before we get into those, let's see the methods of collection interface. First one, add object. This method is used to add an object to a collection. Add all collection C. This method adds all the elements in the given collection to this collection. It adds all the elements of a collection given to the collection interface. Clear. This method removes all elements from this collection. Contains object O. The method returns true if the collection contains a specific element. Hash, hash code. This method uses used to return a hash code value of a collection. Is empty. This method returns true if the collection contains no elements. Iterate. This method returns and iterate over elements in this collection. Max. This method is used to return the maximum value present in the collection. Remove object O. This method is used to remove the given object from the collection. If there are duplicate values in this method, removes the first occurrence of an object. Remove all collection C. Method is used to remove all the objects mentioned in the given collection from the collection. Retain all collection C. This method is used to retain only elements in this collection that are contained in a specific collection. Size. This method is used to return number of elements in the collection. To array. This method is used to return an array containing all the elements in the collection. In this collection. So let's see interfaces that extend the collection. So as I told, the yellow one are the interfaces and the pink one are the classes associated with the interface. List interface. This is a child interface of a collection interface. This interface is dedicated to the data of list type in which we can store all ordered collection of an object. This allows duplicate data to be present in it. This list interface is implemented by various class like list array, vector, stack, etc. Since all the subclasses implemented the list, we can initiate the list object with any type of these classes. So let's see what are those classes. Array list. Array list provides us the dynamic array in Java. Though it may be slower than a standard arrays, but can be helpful in programs where lots of manipulation in an array is needed. The size of an array list is increased automatically if the collection grows or shrinks if the objects are removed or added to it. Java array list allows us randomly access the list. Array list cannot be used for primitive data types like int, char, or etc. We need a wrapper class for such classes. Linked list. Linked list is an implementation of a linked list data structure where a linear data structure where elements are not stored in contiguous location and every element is a separate object with the data part and an address part. The elements are linked using pointers and address. Each element is known as a node. Vector. A vector provides us a dynamic arrays in Java. Though it may be slower than the standard array, it can be helpful in the programs where lots of manipulation of arrays is needed. This is identical to array list in terms of implementation. However, the primary difference between a vector and an array list is that vector is synchronized and array list is not synchronized. Stack class models and implements the stack data structure. The class is based on the basic principle of last in first out. In addition to the basic push and pop operation, the class provides three more functions of empty, search, and peek. The class can also be referred as a subclass of an vector. Next interface. Queue interface. As name suggests, a queue interface maintains the first in first out order similar to the real world queue line. The This interface is dedicated to store all elements where order of the elements matter. For example, whenever we try to book a ticket, the tickets are sold on first come first served basis. Therefore, the person who requests arrives first into the queue gets the ticket. There are various likes like primitive, priority queue, and array DQ, etc. Priority queue. A priority queue is used when objects are supposed to be processed based on the priority. It is known that a queue follows the first in first out algorithm, but sometimes elements of the queue are needed to be processed according to the priority, and this class is used in these cases. Priority queue is based on the priority heap. The elements of priority queue are ordered according to the natural ordering by a comparator provided at queue construction time, depending on which constructor is used. DQ interface. This is very silent variation of queue data structure. DQ is also known as a double-ended queue. Is a data structure where we can add or remove elements from both ends of the queue. The interface extends the queue interface. The classes which implements this interface is ArrayDQ. ArrayDQ. ArrayDQ class, which is implemented in the collection framework, provides us with a way to apply resizable array. This is a special kind of an array that grows and allows user to add or remove an element from both the sides of a queue. ArrayDQ has no capacity restrictions, but they can grow as necessary as they want. Set interface. A set interface is an unordered collection of objects in which duplicate values cannot be stored. This collection is used when we wish to avoid the duplication of an objects and wish to store only unique objects. This set interface is implemented by various classes like hash set, tree set, linked hash set. Since all these subclasses implement the set, we can instantiate a set object with any of these classes. Asset. Asset is a class inherited implementation of an hash table data structure. The objects that we insert in the hash set do not guarantee to be inserted in the same order. The objects are inserted based on their hash code. This class also allows the insertion of null elements. Sorted set interface. In this sorted interface is very similar to the set interface. The only difference is that this interface has extra method that maintains the ordering of an element. Sorted set interface extends the set interface and is used to handle the data which needs to be sorted. The class which implements this interface is preset. Since this class implements the sorted set, we can initiate a sorted object with this class. Treeset. A treeset class uses a tree for storage. The ordering of element is maintained by set using their natural ordering, whether or not an implicit comparator is provided. This must be consistent with equals if it is to correctly implemented the set interface. Can also be ordered by a comparator provided at set creation time and depending on which constructor is being used. Map interface. Map is a data structure that supports a key value pair of mapping of data. This interface does not support duplicate key because the same key cannot have multiple mapping. However, this allows duplicate values in different keys. A map is useful if there is a data and we wish to perform operation on basis of key. This map interface implements by various classes like hash map, tree map, etc. Since all the subclasses implemented the map, we instantiate a map object with any of these classes. Hash map. Hash map provides the basic implementation of a map interface of Java. Stores the data in key value pairs. To access the value in a hash map, we must know its key. Hashmap uses a technique called hashing. Hashing is a technique of converting a large string into a small string that represents a same string so that the indexing and searching operations are faster. Hashset also uses an hashmap internally. This is a brief explanation of collections in Java. Please do like, share, and subscribe. See you in next video. Thank you. Bye.